So here it is. Oh my goodness, isn't that graph? It is. Shifted over to the right by 2. It's because 2 is where you cannot use. So if I plug in a number like 3, I get 1. And if I plug in a number like 0, I get -1. So this is the graph of f of x. So why is it not differentiable at x equal 2? Well, it's not continuous, right? So it's not continuous. I have to lift my pen to draw that graph. Okay, so how would I draw the derivative? How would I draw the slopes of those tangent lines? So slope is, well, all of these slopes are 0. All of these slopes are 0. So there's one point where the derivative doesn't exist, and that's at 2. So I'd have a hole at 2, and everywhere else, the slope of the tangent line would be 0. Okay, so let's review these ideas of continuous and tangent. I don't know why this green thing keeps coming up. I can't get rid of it. Anyway, just wants to be there, apparently. Go away, go away, go away. Yeah, well, okay. So let's look at this graph here. So where is it continuous? Continuous. So where can I draw it without lifting my pen? So there's going to be intervals. So I'm going to start back here at -infinity, and then I'll have to stop at -4 because that's where the asymptote is. And then I'll start back up at -4, and then I can go up to 2, but can't include 2. And then I start back up at 2, and I can go to 4, and then I start back up at 6, and then go to infinity. Good? Okay. I guess we could actually include the point 2 here and include the point 4, but it's not a big deal. I would accept either answer. Another really important thing to know is to find out where the slope of the tangent line is 0. So that means like the top of a parabola, bottom of a parabola, slope is 0. So let's go through. Oh, look at that. I think I purposely tried to make that like a slope is 0. So at x equal -3. And then, no, that's a cuspy thing, and that's a corner thing. Oh, but what about all of these in between here? So I would say all the x values between 4 and 6, but not including 4 or 6. And then when is it not differentiable? Okay, so it's not differentiable at x equal -4 because it's not continuous. And it's not differentiable at x equals 0 because that's a cusp. And it's not differentiable at x equal 2 because it's not continuous. And it's not differentiable at x equal +4 because that's a corner. It's not differentiable at x equals 6 because it's not continuous. And at x equal 8, it's a vertical tangent. So all of those are where the derivative doesn't exist. Okay, so we're going to invest some time in graphing the derivative functions. So here I've given you the f of x, and I drew the axes for f prime right below it. So here, if I was to pick these points here and take tangent lines, looks like the slopes of those tangent lines would be 1. So I'll have a slope of 1 until I get to that corner, and then I've got a hole. Then if I start drawing tangent lines again, the slopes of the tangent lines would be -1. So remember, this here, this axis is the slope of the tangent lines. So whenever you can find where the slope of the tangent line is 0, that's a great starting place. So for B, C, and D, that would be a good starting place. So right here, I see slope of the tangent line is 0. So that means at x equals 0, that f prime is 0. So now let's go and check another tangent line. So if I pick a tangent line back here, so I'm not putting numbers in purposely, just some number back there, that's a negative slope. So that means back here, it's a negative slope. And then if I choose a number over here, that would be a positive slope. So that point, x value right there, would be some positive slope. And then we can just join it together. How about that? So now let's go to this next one. Whoops, whoa, come back. Slope is 0 right there. So at x equals 0, slope is 0. Doesn't matter what the y value is on f of x. So at x equals 0, at x equals 0, the slope is 0. Okay, so let's try some other points again. So if I try some number back here, that looks like a positive slope. So positive slope means above the x-axis, right? Positive slope, let me just write that down. Positive slope means above the x-axis. And then after I get to this slope of 0, so it has to come down to that. And then after that, and I plug in a point here, it's also a positive slope. So it keeps going up. And you'll get to have a sense of like, make it curvy or straight. It doesn't really matter at this point. One more. So let's find out first, again, where the slopes of the tangent line is 0. So I see 2 places. So I'm going to put a slope 0 and then the slope 0. And then I'm going to look and see before that point, it looks like these are negative slopes. So that means below the x-axis. And then if I come in between in here, between these 2 slope zeros, those look like positive slopes. So positive slope means above the x-axis, and then it has to come back down to the 0. And then after that, it's going to be negative slopes again. So down there.